Hi, some of you want to know how to use the Moody chart. So I'm going to explain here again how to use Moody chart. Moody's chart is extremely important for you to solve the problems about this friction loss or head loss. Without this chart, without reading this chart, you won't be able to solve these problems. So Moody's charts give us the value for friction factor. This friction factor is essential component to solve the problem. So you want to know this HL measure, you want to know this pressure drop, you have to know this friction factor. These formulas are there, but without the number of friction factor, you won't be able to solve it. So now in this video, I'm going to tell you how to use Moody's chart. It's very simple. For the Moody's chart, all you need to know is Reynolds number and your epsilon by D, something known as relative roughness. Epsilon is a property of material, it depends on material. If you go through the book table 8.1, you will get the values of epsilon, diameter of the pipe, and together they become dimensionless. Now it is important that this epsilon should be in millimeters. Normally it is given in millimeters, so that make sure that you have it in millimeters, and then convert your diameter, normally given in centimeters or meter, in the millimeter, so that this entire thing is dimensionless. If you let's say get confused, you use this by default value which is in millimeters, and then this diameter if you use in centimeters or meters, in that case you will get different number. If you get number different here, you're gonna get different value here. So make sure that you understand, you take this epsilon by D both in millimeters. Normally epsilon is in millimeter, table 8.1, diameter, convert it into millimeters. Now let's assume that your epsilon by D comes as 0.006. So here 0.006, you have to follow the black line from 0.006. You don't have to draw horizontal from this side. All you have to do is follow the black line, which goes here, somewhere here. And then it goes in upward direction, this black line of 0.006. So you start here, and then it goes like this, upward direction. And then let's say your Reynolds number is 10,000. All you have to do is draw vertical from the 10,000. So 10 to the power 4. If 4 zeros mean 10,000, 5 zeros mean 100,000, 6 zeros means 1 million, 4 zeros is 10,000. I'm going to draw vertical from here like this. And wherever it will lead that black line from 0.006, I'm going to mark a point. And from that point, all I have to do is draw a horizontal. And wherever that horizontal will meet, now here it's 0.039 or so, closer to that, let's say 0.03039. So that's 0.039 here somewhere. That's my number for 10,000 and for 0.06. So you have to follow that black line. Now let's say, let's do some problem here. Let's say my roughness is 0.02 and 30,000 Reynolds number. So first get my 0.02 here. So it says 0.02, which is somewhere here, which is very high, which has very high surface roughness. We go from here, we follow the black line. So this is my black line here, and then it says 30,000, 30,000, 20,000, 30,000 here. I'm going to draw vertical here like this, and wherever that will meet, from that meet to this black line, from that line I'm going to draw a vertical, horizontal, sorry, from that point. So here it meets here, and then I'm going to draw a horizontal, and then it comes around 0.05. So that's my answer, 0.05. Now let's say my Reynolds number is 70,000, and then this one is 0.004, my surface roughness here. So I'm going to follow the black line for 0.004. So this is the black line, it goes upward, don't draw horizontal. Follow the black line, the black line goes upward somewhere here. And then 70,000, draw a vertical from 70,000. So find the 70,000 on x-axis, make sure that you know how to do that. 60,000, 80,000, 70,000 somewhere here. I'm going to draw vertical, and then that will meet somewhere here. From this point, once these two, this black line which is going slightly upward, and then vertical from my x-axis. From that point, draw a horizontal. And wherever that will meet, that will be my friction factor. So 0.03, that's my friction factor. And then finally, it says that 0.004, 220,000, well, it should be easy now. 220,000, first x-axis, 220,000. So I have 100,000 here, 200,000 here, 220 should be somewhere here. So from that I'm going to draw a vertical. And then it says 0.0004, that's 3 zeros and 4. So here 0.004. I'm going to follow the black line. The black line goes upward direction. Here, where it goes here, upward here, and then it meets somewhere here. Now from this part, I'm going to draw a horizontal. So that horizontal will look something like this. Sorry, here. And then wherever that horizontal will meet, that will be my number, which is around here as 0.018 or 185, either is fine. That's the number I'm going to take, and then I can do this Moody's chart. So do practice this chart at home. If you can't understand, hit me an email and I'll explain it how this chart works. Meet me in my office or after the class, and I will tell you how this chart works. So it's very important. If you can't learn how to read Moody chart, you won't be able to solve the problems. So make sure that you understand how to use this Moody chart to get this friction factor here. So that's pretty much on this video, how to use Moody chart.